So I'd like to start by introducing firstly Suzy Roy, Yongsheng, where's he? And Alejandro Lopez Osornio. I saw him somewhere as well. Oh, he's there as well. Yeah. All my colleagues from SNOMED International, and they will be presenting the IPS terminology, promoting the International Patient Summary adoption and implementation. Over to Suzy. Thank you.
Thank you so much. Hello. Thank you everyone for joining us today. Yang and Alejandro, do you guys want to not be frightened? You guys can come up now so that we don't take too much time. Yeah. Slide advance. Yeah.
Am I meant to do something?
Nope, got it.
Oh.
We're all good now. Hi, and so as Jane alluded to, we're all colleagues for SNOMED International. You are all here attending the SNOMED CT 2022 Expo. So I'm not going to go into a lot of detail. Otherwise, I wanted to just point out here that we have a number of countries filled in various shades of blue, where we have our 43 affiliate members. But we also have other shades of blue where we have affiliates who have a SNOMED CT license as well. But there are also a number of other countries that are not filled in any shade. And those are some of the additional countries that we want to make sure that we continue to support in addition to our members. And so some of our involvement in the IPS work, the International Patient Summary work, directly involves many of those in those countries. Maybe, there we go. So I am actually not going to go into a huge deep dive into the International Patient Summary because we had a couple of presentations last year on the IPS, and we also have my colleague Rob Howsam, I think I saw it in the room earlier. Hi, Rob, who will be presenting immediately after us, and I don't want to step too much on his toes either in talking all about it, but I will say that the IPS is a minimal and an exhaustive summary set that provides a healthcare summary of an individual at a particular point of time. And essentially, what you really need to know is what they presented this morning at the keynote presentation. Karen Johnson provided a great overview of the importance that has been designated on the International Patient Summary adoption and implementation at the G7 level, as well as with the Global Digital Health Partnership, GDHP, with our other colleague members, Herco and Alistair from Netherlands and New Zealand, respectively, showcasing some of the various SNOMED member countries that have adopted and want to implement the IPS. And so luckily, SNOMED International, we have joined forces with a number of our global partners, our global collaboration partners, such as HL7, IHE, CEN, ISO, to really be part and included in this whole ecosystem that helps to produce various artifacts that can be used for IPS adoption and implementation that is being really encouraged by G7 and GDHP.
Oh, yeah.
Where did it go? There we go. Joe. Okay. And rather than going into huge detail here, again, I just really wanted to show that SNOMED CT is right there in the center because SNOMED CT provides the terminology that is used in IPS implementation. And as I mentioned, we work with all of our global partners, such as CEN and IHE and HL7, who also provide other artifacts within this ecosystem. But we're primarily going to focus on the SNOMED CT artifacts today. Okay, I'm pushing the wrong button, maybe. You have to push two times. Yeah. And in order to provide the terminology that is needed for IPS implementation, we have for a number of years now collaborated with HL7 in creating the SNOMED CT HL7 IPS Free Set. This is a flat list of codes, all of the codes that are needed by both CEN and HL7 for any of the IPS, the HL7 IPS value sets. Any of the concept codes that are needed in those value sets are found in that flat list. Of course, then some of our members, such as you saw today, Herco and Alistar, saying that Netherlands and New Zealand are going to be implementing IPS. Some of our members started indicating that they also wanted to use IPS. And the flat list for them is not going to be sufficient because, of course, they have SNOMED CT in the full edition form. And so we started to create the SNOMED CT IPS reference set. The ref set is essentially a SNOMED CT ref set that is based on the IPS free set, but available in RF2 specification. So anyone who's implementing SNOMED CT already in a member country or with an affiliate license can pick up that reference set and implement IPS. So of course, in the last year and a half, we've done some incredible research, which my colleague Yang is going to be talking about, to create sub-ontologies of SNOMED CT. And one of the first things that we decided to do was look at the IPS and try to see if we could create a sub-ontology of the IPS, of SNOMED CT with the IPS, and thus we have created the IPS terminology. So the IPS terminology is a free sub-ontology of SNOMED CT that is based on the International Patient Summary free set that we have created. And so I'm going to actually hand it over to my colleagues, Yang, who's going to tell you how we've created this set. And then I'm going to hand it over afterwards to Dr. Alejandro Lopez Osornio, who's going to then tell you how you can implement these resources. Yeah.
Okay. So as Suzy just said, from the beginning, just a list of codes, then suddenly changed to a terminology. So actually really is a sub-ontology of SNOMED CT. So that is a new concept, a term we're talking about here. So what is a sub-ontology? Really, we don't have a formal definition. Just say, okay, it's a customized standalone ontology, but that is extracted from a source ontology. That's it, sub of something, subset. But we want to describe that really in some key features. So what in it and what criteria to create such a sub-ontology. So first, we want to preserve the semantics, because if you look at a list of code, really just look at term rather than the hierarchical structure, the logical definition. Those are not there unless you go to the full terminology. So if we get this concept model in, then just like run into a rabbit hole or pulling a string, you just get more and more and more concept into this sub-ontology. So we have to decide where's a stopping point. Say, okay, that's enough, it's enough. That's all what we need. So we make a clear distinction about focus concept and the supporting concept. In this context, the focus concept is the list from the IPS. So that is what people are interested in. All the rest concept supporting the logic definition actually called supporting concept. Those are relevant, but we don't need the full semantic of those concepts. So that's the key difference here. The semantic actually in two different kind of definition. Focus concept have full meaning. Exact logical definition, if you look at that, is the same as if you look at entire SNOMED. But look at the supporting concept, that's a little different, that's simpler. It's become just hierarchical, same as in the SNOMED. So that's the preserved semantic. And then we want this concise, smaller. We don't want things are not relevant to be within. So that's, as I mentioned earlier, we have to get rid of things that are not relevant, just don't want to keep pulling the string. So that's the conciseness. Then the customizable. So sub-ontology not just say it's fixed. Okay, you can only have this sub-ontology. Actually, we produce different sub-ontology for our testing purpose. For example, nursing sub-ontology, dentist sub-ontology, quite a few. We also ask our expert group to provide feedback, see how that sub-ontology looks like. Is that fit for purpose? We got some quite good feedback. And also this should conform to the standard as a standard organization. And this confirmed not only just IF2, our release format, this confirmed to the international standard for R2 ontology standard. So this is the development really is under project, and we were fortunate got funding from the UK EPSRC Impact Acceleration Award, and also University of Manchester, SNOMED International. So we joined force together with expertise, with resource. So we have Warren as a full-time contractor work for us for a whole year and develop software. And also we under the guidance from our steering group, James there, and also Rory and Monica to really say, okay, this is what we want to achieve. Don't do too much because we need to finish this in a year time, because a lot of projects just keep running, that's can't deliver. So that means we need to finish on time and deliver what we promised. The sub-ontology extraction really needed to support the full semantic of SNOMED CT. That is under the R2 EL language profile. If you look at the before the logical profile enhancement, it's quite simpler. You have attributes value. But now we have more things, for example, GCI axioms and role chain and data type and transitive reflexive properties. So those added complexity is not easy to compute. So we have to look at all the different logical construct to say, okay, how we handle those, not losing the semantic. So that's almost like write a new program to get generated sub-ontology. So people may ask, what's the difference between this sub-ontology and the module? Some people may play with module. The key difference is, as I mentioned earlier, we have distinction about focus concept and the supporting concept. Module does not, just pulling string everything. And also we have the logical profile is different. So that's a particular what we focus on. The tooling is freely available. As an organization, we encourage using the open source, and this tooling you can download from HSDL, GitHub, so you can run the Java programming and put into a list of concepts, you get a sub-ontology. And also we have a number of examples during the development. That is a link, you can have a look. So how do you generate this sub-ontology? So it's straightforward, I would say. All you need to just input is a list of concept, either a ref set or just you have a list in your spreadsheet, whatever text file. And then it's just need a source ontology in the context SNOMED CT, whatever the edition you're running, not only just international edition. If you are in the national extension, you want to generate sub-ontology, you just use your national extension as a source ontology. Key computation here, just trying to explain a little further what had been computed, included into this sub-ontology. First, we do the conversion, convert this logical definition to the authoring form, basically proximal primitive parent modeling approach, because there are different approach in different countries. Some use close parent, some use proximal primitive. So we have the consistency. So everything will convert to authoring form. And also we expand the supporting concept, say what supporting concept needed. So automatically achieve this. So identify supporting concept, handling all the dependencies and the logical constructs. So that's the how do we automation software works. And then we say, okay, the initial feedback we got it. It just say, this looks strange because initial sub-ontology didn't put the top level category concepts in there. So it's just like a concept suddenly gets a very long list of concepts at the beginning. You say, SNOMED CT is well structured, then this sub-ontology is kind of a flat list like some area. So we include the top level ontology. I think that is useful as well because like most people here familiar with hierarchy. So you normally just say, okay, I'm looking for the clinical finding, go straight to that sub-hierarchy. So that is why this is included at top level. Then it's shrinking the sub-ontology hierarchy. As I mentioned, the supporting class, actually not relevant, a lot of concept. So those will be thrown away. So the hierarchical structure actually much shorter than you expected. Of course, once we construct this by software, then we need to validate this sub-ontology as we promised. As I mentioned, the two key semantic rule. It's a full semantic of focus concept, and all the concepts in sub-ontology should have the transitive closure, same as the source ontology. The output, standard IF2 format and alpha format, so that's easy to integrate to your use. So this is just put in the context of what it looks like. So left-hand side is the current SNOMED CT, not current, 2021, when we was doing the testing. You see the list of concepts. So you got the common concept in each sub-hierarchy. I highlighted this, that means these are not included IPS, because when we generate sub-ontology, we look at the top level categories. And if there's no such sub-concept included in the IPS, then this top level don't need it. So that means these are not in the IPS. So that's on the right side, you see the IPS sub-ontology look like. So you can easily see the number difference for each sub hierarchies. Clinical finding, of course, people are focused on clinical finding. Procedure, body structure, you can see the number of those. So that is the quick overview about how we construct this and what it look like. It's just like functioning terminology. That's why I start to call it IPS terminology. I think that's covered all. And to Alejandro.
Well, there are some animations. So let's talk a bit about how you use the sub-ontology in a real setting. This is an example of the sizes. Yes, previously when we didn't have the sub-ontology, we had the IPS. It's making some noise. So the old IPS reference had 80,000 codes. And following the process that Young described, there. What we did is to extract the sub-ontology that actually is compatible with the terminology server. Before, with a list, you could put the list in the table and search on the list, and that's all you can do. But the sub-ontology can be loaded into a terminology server, and you can actually run, for example, expression constraint queries over the sub-ontology. You can navigate hierarchies, you can group, you can see attributes, and this is how it works. The total size is 50,000 concepts, so it's almost double the size of the IPS ref set because of the attributes and all the supporting concepts that was described. The IPS terminology is a free alternative for users of SNOMED CT that don't have a license, that they are not in a member country or don't have an affiliate license. They can use the IPS terminology, and the member countries should use the complete SNOMED CT edition, even the national extensions, but they have the IPS ref set available in order to make conversions and to understand what may be available for a second party that may receive their data. So we discussed the use of ECL, and ECL is the language used in SNOMED CT for queries and for constraining information. It's called the expression constraint language. And we will show very quickly two use cases for ECL. And the main one is terminology binding. For example, Rob is working, and he will discuss this in the implementation guides for the IPS. And when you see the implementation guide of the IPS and you see what's the link, the terminology binding between a field, a property in a resource, and the terminology, you will see an expression like this, like types of clinical finding, events, or situations. And the same expression is compatible with any version that you may have available of SNOMED CT. The difference is that the number of concepts available will be different. But if you have the international edition, you have 124,000 concepts. If you have the US edition, you have 129. You have the Canadian edition, you have 124.6. And if you have the IPS terminology, you have almost 7,000 clinical findings that match this expression. But you can use the same expression and you can run it in different resources. And that's you don't need to make a different implementation of the IPS, depending if you have your national extension, the international edition, or the IPS terminology. And when you want to share information, this is interesting, is how do you, if everyone is using their own codes, how this is interoperable? How can we share something that is understandable by the other? And this is when ECL is also useful to detect common concepts that we have all and we can share, yes? So one possibility, HL7 allows you the possibility to send more than one concept for a condition, for example. So you can have your national concept for a condition, and you can provide also an international concept for people who are outside your country. They share the international edition with you, but they don't know your national concepts. And you may also add an IPS terminology concept, for example, that will allow people who only have the IPS terminology to understand it. And if we see an example of this, let's say I'm using in my national extension opercular epilepsy, which is a very precise and definitive concept for epilepsy, which I don't know if will survive the epilepsy redesign that was presented today. But opercular epilepsy is very detailed, but it's not part of the IPS terminology. So how do I share this information with a country that doesn't have the complete SNOMED CT? They only have the IPS terminology. If I run a fire expand into an intentional value set using this language, what you see there is an ECL query. It's a syntax that allows you to extract information from a SNOMED CT. And you can run that over any SNOMED edition. And that will identify the closest concept in a SNOMED CT that is part of the international edition. So when you share opercular epilepsy with a country that doesn't have access to the full SNOMED CT, maybe you want to share also as a secondary code localization-related epilepsy. And those countries globally, this concept will be fully understood because it's part of the IPS terminology. But you retain the previous one with more detail for other members of SNOMED CT, for example. And that's a facility that we have in FHIR that we can represent the same meaning with different levels of detail. So thank you very much.
So I will just say, because I saw a lot of people trying to take pictures, and I'm not sure if you could get the full picture, these slides will be posted, or you can just contact any one of us and we can get those slides to you right away. Go ahead.
Okay, so thank you, thank you, the three of you. And we will now take questions. I don't have any online. I have a couple in front of me as prompts, but which are good. But does anyone have any questions from the floor? I'm going to start running.
I actually have two questions that I think are mostly for Yang, and I am curious if you could say any more about how you shrunk the hierarchy and what was involved in that. I'm sure I quite got that. And I got another one, but anyway, you want to...
Okay. Okay, it's just for the shrinking the hierarchy, right? For example, if supporting concept hierarchy, the substance anatomy, and if you look at the clinical finding that has been defined by substance, because toxic or the allergy or the other conditions related to body structure, and based on the focus concept, we can identify the body structure relevant to support the definition, substance that's required for supporting. Then we look at those identified concept, the link between them. We will ignore any concept in between that are not referenced. So therefore, those hierarchy actually become much shorter. But as long as they have the relationship, has been referred body structure, referred substance, they have the hierarchical structure, that will be preserved. But any additional concept that you never refer by the focus concept, that is meaningless to stay there. So that we throw away. And this is from the pure primitive hierarchy. But for the defined, even clinical finding hierarchy or procedure hierarchy, those actually a little bit complex because it involves the primitive concept that quite difficult to get rid of, because that is the one kind of concept you need to keep that to preserve the semantic. And also you have certain concepts that is within the IPS, but some concepts are not and has a relationship. So there's quite a lot of complex computation in between for the procedure. So this is why we did the Austrian form conversion first. So reduce the reference the concept. Yeah.
Great.
Can I come back to you? Can I just, I will come back to you. Or you can ask from the platform.
Thanks for your presentation. I wondered if there's no term available in the IPS and you go to the proximal ancestor, do you have any estimation about the coverage of the, for example, the international edition? Like how many concepts could you support, because that would not always be possible?
Well, the coverage depends on the use case, but you have for these 15,000 concepts in the IPS, and you have like 300,000 concepts in the international edition. So there's a gap, but the IPS was selected based on frequency of use. That it was based on the NLM core subset, so there is real clinical experience behind that selection. So we hope that the most common things will be present on the IPS.
Are there any more questions? Oh.
I have one that just is very high level. Suzy, you presented an initial slide that just showed the, what it's trying to do and allowing a patient to take a record anywhere.
Yes.
I'm missing then, why aren't staging and scales? Because with any type of thing, why aren't they included? I mean, what am I missing here?
This is something that is, like I said, a cross collaboration between a number of organizations. And actually, one of my colleagues here, he's involved in both the ISO and also the IHE, the HL7 side, who are actually creating it. We are just supporting it with the terminology. We don't actually create the minimal data sets that actually go into that.
Basically, what Suzy's saying, you can blame me.
And Rob is going to talk next, so
Yeah,
perhaps
yeah.
you can come back on that one.
It's a great question.
Before I let Rob go again, is there any other questions in the room? Okay, there you are. You can answer the last one.
Okay. Well, my other question was a bit technical, I guess, but I was curious if your sub-ontology extraction, how much it might be based on the module extraction algorithms that are now, I think, originally from Manchester and now in the LAPI. Is it?
Yeah, actually, first step is to use modularization. That's a quite straight answer, because we don't want to compute the entire SNOMED CT. That take quite long. So we do the modularization first, then start from there, because modularization preserve everything single schematic. Yeah.
Thank you.
Thank you.
I think that's it. I mean, I think we will actually continue this discussion, I'm sure, after the next presentation. But before Yong sits down or disappears, I would like to thank the three of you very much for your presentation. By normal PS, thank you very much.